Good afternoon. In this video session, I would like to discuss about surface modeling of a cuboid. Surface modeling of a cuboid. So basically, what is that we are trying to find out is this is a cuboid. This cuboid has got 8 corners 1, 2, 3, 4, 5, 6, 7, and 8. 8 corners. And in these 8 corners, 6 faces will have 8 corners will have, and 12 edges, 6 faces and 8 corners. So you have to vary for each face. This is U and this is V. U is varying from 0 to 1. V is varying from 0 to 1. When U is varying from 0 to 1, you have to get one coordinate on 2, 3 edge and one coordinate at 1, 4 edge. Okay, and from V is equal to 0 to 1, you have to identify one coordinate x, y, x and y. So this is how you have to generate various coordinates on each and every face. So for this actual 3 coordinates of 8 corners, you identify, get the data of x d1, y d1, x d2, y d2, x d3, y d3, x d4, y d4, x d5, y d5, x d6, y d6, x d7, y d7, and x d8, y d8. So this is the 8 coordinate data. So when we are trying to project this particular cube in xy plane, x, y, z, xy plane. So here you have to get draw 6 planes. Plane x2, xd2, yd2, xd4, yd4. This is one plane. Plane xd3, yd3, xd8, yd8. Plane xd2, yd2, xd5, yd5. Plane xd6, yd6, xd8, yd8. Plane xd2, yd2, xd5, yd5. Plane this is yd4, xd3, yd3, xd6, yd6, xd8, xd2, xd5, yd5, and xd2, yd2, and xd7, yd7. Okay, so these are 6 planes, and this is the end of the program. Now in this each plane, we are trying to get the coordinate data of xy points in each surface, and we are storing that in a database, or we are displaying that data in the computer screen. So here, color blue, color green, color red, color yellow, color white, color violet. So there are different colors. We are playing different planes. Now we will write a program for this plane in separate algorithm. That is plane x1 y1 x4 y4. That means we are trying to get the two coordinate data. One is here and another one is here. Two coordinate data xd2 y2 xd4 y4. This particular data we are getting. So after getting this here in this plane algorithm, you have to get x2. x2 is equal to what? So if you say this is x3 y3, if you put x3 x3 y3, you are placing 1 and 3. Or otherwise you can put like this 2 and 4. This is 2 x2 y2 and this is x4 y4. So you are trying to get x1. x1 is equal to x2. y1 is equal to x4. This particular coordinate data is got. Similarly, x3 is equal to x4, x3 is equal to x4, and y3 is equal to y2. So you got 4 coordinates. For these coordinates, it is a plane. Now it has got a plane has got 4 coordinates. In this plane, we are trying to generate a coordinate on the plane. So u is equal to 0. This is a parametric value. Du is equal to 1 by 200. Similarly, v is equal to 0. dv is equal to 1 by 200. Okay. Now, for u is equal to 0, u less than or equal to 1, u is equal to u plus d. Now, in this case, now what is that we are trying to do is, you are incrementing u in this direction and getting 2 coordinates on 2, 3, 8 and 1, 4 edge. So, total here 2 values. So, you are getting S1 is equal to 0, S2 is equal to 0, S3 is equal to 0, S4 is equal to 0, and apart from this, each point would have one coordinate or x5. So S5 is equal to 0 and S6 is equal to 0. So there are the various values of. So basically, what is that we are trying to do is S1 is equal to S1 plus u into x3 minus x2. S2 is equal to S2 plus u into y3 minus y2. Similarly, S4 is equal to S3 is equal to so 1.32 is got, and S3 is equal to S3 plus u into x4 minus x1. Between these 2 points, 1 point I am trying to find. Thus S4 is equal to S4 plus u into y4 minus y1. So here you are getting x11 is equal to S1, y11 is equal to S2, x22 is equal to S3, and y22 is equal to S4. So for 2 coordinates, that means you are getting one coordinate x11, y11, x22, y22. For v is equal to 0, now we have written v is equal to 0, v less than or equal to 1, v is equal to v plus dv. Now here again you are getting, so S4, now here before going into this particular loop, you are trying to get S5 is equal to 0 and S6 is equal to 0. These are the two sums you are trying to make, because you are completing this for loop and again go to U loop. So E is equal to Z, E is equal to Z. So here what is that you are trying to do? S5 is equal to S5 plus V into X22 minus X11. S6 is equal to S6 plus V into Y22 minus Y11. And X is equal to S5, Y is equal to S6. Plot pixel XY. And this is one end, this is another end. So this is how, that means one plane you are getting x2, y2, x4, y4 you are getting, and you are determining x1, y1 and x2, y2. So x1, y1, x2, y2, x3, y3, x4, y4. Four coordinates for each plane you are trying to get, and in each plane you are trying to get several points of in this plane, and then you are displaying that point in blue color, in green color, red color, yellow color, white color, and violet color. So this is about surface modeling of a cuboid. So in the earlier video session, you have seen how to draw a bi-frame model, and in the next video session, you can see how to draw a solid modeling of a cuboid. Okay. In the solid modeling, the surface data is not enough, but inside the surface. So you have to get, so for example, this is length A, width B, and height H at C. So the total number of pixels is A into B into C. So this many number of pixels you have to find out in solid modeling. So in surface modeling, so 6 faces and 6 faces are there. So 2 into AB plus BC plus CD. These are the number of pixels you are trying to generate in case of surface modeling. In a straight line, so how many? A plus B plus C. Number of pixels you are trying to show representing in case of a wireframe model. So there are 3 different models that we are trying to show. So basically, each plane, 2 corners data I am taking, and 6 planes, and this plane is a function. And in the function, you are trying to get the 2 coordinates on 2 edges, 2, 3, and 1, 4. And in between these 2 points, you are trying to generate the coordinates. So this is how you can draw a program for surface modeling of a cuboid, and this is just a 10 minutes program, and you can generate a beautiful surface model for a generator. And the other part of problem, that means the future work of this particular cuboid representation, you can rotate this particular cube in different orientations and get different coordinate data, xd1, yd1, xd2, yd2, xd3, y3, yd3, xd4, yd4, xd5, yd5, and xd6, yd6. And then you're going to represent this in six different plates, and you're going to get this particular. So this is what I would like to discuss in this particular programming. So thank you for watching the video.